Hi, good evening. Welcome to Vetrii NEET Gateway. In today, I am going to discuss very important reactions regarding haloalkanes and haloarenes. The question number first: which of the following nucleophile is going to promote an SN2 reaction? That is bimolecular nucleophilic substitution reaction, SN2 reaction. Actually, the solvent we have to use for SN2 mechanism, polar aprotic solvent. Polar aprotic solvent. Polar aprotic solvent. The polar aprotic solvent we have to use, as well as nucleophile is strong nucleophile we have to use, right? So here for SN2 mechanism, very good nucleophile is sodium iodide. Sodium iodide I minus is a good nucleophile here. So we can take first option is the correct answer for this question. Yes. Then move on the next question. The question number 2 on the screen. The compound treated with sodium iodide acetone, that is SN2 condition. SN2 condition gives rise to product. Product of the reaction is SN2 reaction single step reaction. Product formation is inversion. The single product formed here. Right? Na plus I minus is our nucleophile. Here alkyl halide, that is bromine and chlorine is there. The rate of reaction order, rate of alkyl halide is Ri is greater than RBr, then RCl, then RF. Then we have to consider here Br and Cl. Br is a good leaving group here. Now this is a good leaving group now. Good leaving group comparing CHCl, right? So the attack of nucleophile is backside attack takes place. So then we are getting inversion product, we are getting here CH3IH, then Cl here, H here. Inversion product we are getting, that is option C is the correct answer. Inversion product, Walden inversion takes place. So that is option C is the correct answer. Then move on the next question. Question number 3 on the screen. Among the following, which is most reactive in SN2 reaction? SN2 reaction, for SN2 reaction, rate of reaction is primary alkyl halide, then secondary alkyl halide, then tertiary alkyl halide. Because of intermediate is for SN2 reaction transition state. There is no proper intermediate, but we are considering transition state is intermediate. That is nothing but a carbanion like intermediate. So the rate is inverse relation with the steric endurance. That is less substituted one, more reactive in case of SN2 mechanism, and also rate is equal to Ri, Rbr, RCl and so on. Now here CH3Cl is there, vinyl chloride is there, and phenyl chloride is there. Here CH3Cl is there, CH3F is there, and least reactive CH3F here, least reactive CH3F. So finally, so your phenyl halide is double bond character, and the same time vinyl halide also double bond character. It won't lose as a leaving group here halogen. But comparing first and fourth option, CH3Cl, Cl is good leaving group. Comparing CH3F, that's what option 1 is the most reactive reaction for SN2. Yes, then move on to the next question. Question number 4 on the screen. Question number 4. K1, K2 are rate constant for below reactions. Correct relation is R. K1, K2 rate constant or specific rate. Your ethyl bromide treated with NaOH gives rise to ethyl alcohol, and NaBr is a byproduct. That is a reaction 1. This is the rate constant K1. And also this tertiary carbon attached CH2Br treated with NaOH and gives rise to corresponding alcohol. That is the K2 is the rate constant, right? So in this rate K1, K2, they are asking rate of K1, K2. SN2 reaction is SN2 reaction. For SN2 reaction, rate is inverse relation with steric endurance. So less branched alkyl part is more reactive, right? So that is the reason K1 is greater than K2. K1 is greater than K2, we can take due to rate is inverse relation with steric endurance for SN2 mechanism. Less substituted alkyl halide is a more reactive. That is K1 is greater than K2. Yes. Then move on the next question. Question number 5 on the screen. From each of the following pairs, select the compound that will react faster with sodium iodine acetone. Sodium iodine acetone is a SN2 mechanism. Acetone is a polar aprotic solvent, favors SN2 mechanism. Nucleophilic bimolecular substitution reaction. So your rate is Ri greater than RCl, then RBr, then RCl, then RF. And also primary alkyl halide, then secondary alkyl halide, tertiary alkyl halide rate we should consider. Right? 1-chloropropane. You take 2-chloropropane it is. 2-chloropropane. They are given here 2-chloropropane, 2-bromopropane. Here 1-bromobutane. Here 2-bromobutane. Comparing compound 1 and 2. In A, comparing compound 1 and 2, bromine is more reactive comparing with the chlorine, because of both are secondary position. Bromine is good leaving group here. Comparing chlorine. So that's what for A, 2 is greater than 1. So A, 2 is greater than 1, that is 2 more reactive. And in case of B, 1-bromo, 2-bromo. 1-bromo more reactive. That's what option 3 is the correct answer for this question. Yes. Then move on to the next question. Question number 6 on the screen. Correct order of nucleophilicity in polar protic solvent. Nucleophilicity increase with increase in size. Increase with increase in size, right? In case of polar protic solvent, PPS, that is I minus more than Br minus, then Cl minus, then F minus, nucleophilicity order, right? That is the option 1 is the correct answer. Then move on the next question. Question number 7 on the screen. Correct order of nucleophilicity in polar aprotic solvent. Polar aprotic solvent like acetone, dimethyl sulfide, acetone, like dimethyl sulfide, we are observing SN2 mechanism. SN2 mechanism. The nucleophilicity order increase with decrease in size in polar aprotic solvent. Polar aprotic solvent is the condition. That is the reason F minus is more reactive, then Cl minus, then Br minus, then we have I minus. Right? Because of the solvent is acetone, like aprotic solvent. So this is the correct order. Option 2 is the correct order. Then question number 8 on the screen. Which of the reaction shows below will be faster? Below will be faster. Oh, yes. So this is the reaction 1. This is the reaction 2. Both are primary halides. Primary halide treated with KOH water here, and primary halide KOH crown ether. Is the crown ether. Right? Actually, this is we are observing SN2 mechanism. So both are SN2 mechanism. KOH strong nucleophile. So polar aprotic solvent is favor. Polar aprotic solvent is favor comparing with polar protic solvent. So that is the reason reaction 2 is faster than reaction 1. Because of solvent is, this is the PAS, polar aprotic solvent. Right? So that is option 2 is the correct answer for this question. Then move on the next question, question number 9 on the screen. Without exception, SN2 reaction at chiral carbon gives. Without exception, SN2 reaction at chiral carbon gives. SN2 reaction, if I am taking SN2 reaction, alkyl halide, some X, Y, Z, this is a chiral carbon. Sorry, this is the, I have take this one, I have take H. This one I am taking H here. This is the leaving group now. Whenever I am taking nucleophile here, so the attack of nucleophile, backside attack takes place and forms pentavalent transition state like this. Pentavalent transition state, H, here a Y, here Z, and also we have like X, right? So this is the pentavalent transition state. Pentavalent transition state. So it is a concentrated step, actually no intermediate formation, single step reaction. Inversion product is a major, that is only single product formation takes place. Then slowly the X is the leaving group, X come as X minus, then we are getting your nucleophile, then this is the X, this is the Y, so this is the H, here Y, here Z. So like this one, only single product we are getting. That is the chiral carbon means single product. That is chiral carbon is single stereoisomer. Only one stereoisomer is formed. One stereoisomer is formed, right? So there is no enantiomer of substrate like a product opposite polarity diastereomer mixture. Only one stereoisomer is formed. There is only one stereoisomer is formed because of Walden inversion product we are getting. Only one product, 100% inversion product we are getting here. 100% inversion product we are getting in this SN2 mechanism. 100% inversion product we are getting. 100% inversion product we are getting. Right? That is option 4 is the correct answer. Then move on the next question. Question number 10 on the screen. Question number 10 on the screen. Which of the following alkyl halides gives the slowest SN2 reaction? SN2 reaction, for SN2 reaction, rate is inversely proportional with steric endurance. Steric endurance. So less substituted one, more reactive for SN2 reaction. And also rate alkyl halide, then alkyl bromide, then alkyl chloride, then alkyl fluoride. Right? So they are asking here slowest SN2 reaction, more substituted one, slowest rate. Slowest rate, more substituted one. So this is the ethyl chloride, isobutyl chloride. This is the tertiary carbon attached with chlorine, tertiary carbon. So this is the 3 degree carbon, tertiary carbon. This is the 2 degree carbon, right? So this is the more substituted one, slowest rate we are observing. Option 3 is the correct answer for this question. Yes. Then move on the next question on the screen. Question number 11. Which halide react most rapidly via SN2 mechanism? SN2 mechanism. So rate is alkyl iodide, alkyl bromide, alkyl chloride, then alkyl fluoride, right? And also rate is 1 degree halide, then 2 degree, then 3 degree alkyl halide, right? So that is the reason. This is a tertiary alkyl iodide, tertiary. It is also tertiary alkyl chloride. It is a secondary alkyl bromide. It is a primary alkyl iodide. Primary alkyl iodide. Right? So this is the faster, most rapidly via SN2 mechanism. Most rate of reaction we are observing. Option 4 is the correct answer for this question. Then move on the next question. Question number 12 on the screen. Major product P is, so K plus SH minus, strong nucleophile. This is a strong nucleophile. That is SN2 mechanism is favors. SN2 mechanism is favors for this mechanism. SN2 mechanism means 100% inversion product is possible. 100% inversion product is possible. That is Walden inversion takes place. Walden inversion. So here this is the secondary alkyl bromide. It is the phenylic. This is the phenylic bromine. This bromine in conjugation, double bond character. So this is a double bond character. So it is not good leaving group. This bromine is not good leaving group. Now this bromine is a good leaving group now. At K plus SH minus. So this SH minus will attack backside. Then we are getting dotted line compound. Dotted line SH compound we are getting. Here bromine still be there here. And dotted line SH, then here CH3. Yes. So for this observation, option 4 is the correct answer. Right. Then move on the next question on the screen. Question number 13 on the screen. Arrange the following in order of their nucleophilicity in protic solvent. So protic solvent, the nucleophilicity order. protic solvent nucleophilicity order for SN reactions, nucleophilic substitution reactions, in presence of protic solvent, in presence of protic solvent, we have to consider here methoxide. Methoxide is more nucleophilic nature than phenoxide. Then we have to take acetate ion, CH3 C double bond O minus. This is acetate ion, right? In presence of protic solvent nucleophilicity order. So that is option 3 is the correct answer for this question. 2, 1, 3. Then move on to the next question. In which of the following protic solvent SN reaction will occur most rapidly? For SN2 reaction, strong strong nucleophile is required. Strong nucleophile is required. So, and also rate is direct relation with concentration. Strong nucleophile rate is direct relation with concentration. Higher the concentration, higher the nucleophilicity character, right? Higher concentration area 1m, here 2m, here 3m. So we can take 3m is the highest concentration. Option 3 is the correct answer. Then move on the next question on the screen. Question number 16. The following groups, the order of leaving group ability. Leaving group ability, we have leaving group ability. The leaving group ability increase in electron withdrawing groups. Increase in electron withdrawing groups attached to alkyl group. It is more stabilized by carbanion. Right? So that is a reason. Here CF3, these are the esteric form of sulfonate ester. Sulfonate ester derivatives here. Here 3 fluorines attached to this ester. Here 1 methyl attached. Here methoxide is there. Here acetate ion is there. So that is the reason 3 fluorines attached to it. So this esteric form 3 fluorines attached here. Methyl group attached. So ester group is more like good leaving group than others. So 4, 3, 1, 2. 4, 3, 1, 2. Option 2 is the correct answer for this question. Yes. Triflates, mesylates, acetate and methoxide. Methoxide we are considering order. Then move on the next question. Question number 16 on the screen. Consider the following 2 anionic molecules. Which of the following statement is true? One is more basic and more nucleophilic than 2. Base and nucleophilicity. Base and nucleophilicity they are comparing. Base and nucleophilicity. Base means capture the H plus ion. Nucleophilicity means will go and attack on the electrophilic center. Will go and attack electrophilic center. Right? So more the size, more will be the nucleophilicity. Nucleophilicity. So that is the reason. Basic strength O minus S minus O minus good base because of readily attract H plus, more electronegative also. So phenoxide I am taking more than S minus. Then nucleophilicity order, sulfur and S minus and O minus, S minus more size. So nucleophilicity order we can take opposite to basic strength. Then phenoxide. Yes. So that is the reason. One is more basic. O minus readily abstract H plus because of more electronegative comparing sulfur. One is more basic but less nucleophilic than 2. That means nucleophilicity more for S minus due to size bigger comparing oxygen. Yes. So that is the reason option 3 is the correct answer for this question. Thank you, children.